Hello.
Hello. Yeah, thanks. Uh, Hello. Hi, Vishwajit. Hello, Manisita.
Hello, hi.
Yeah. So yeah, it's already 4:05. So let's start. I think since this week has a little less amount of content, so yeah, I think that's why. Yeah, that's why I think yeah, very less amount of attendance is there. It's okay. We will start. If you guys have any specific doubt, then yeah, discuss that. Otherwise, yeah, I'll go through all the question once. And yeah, after that, I think yeah, hardly 30 to 45 minutes. In 30 to 45 minutes, we will cover the session. What I'm assuming. Yeah. And yeah, if you guys have any questions, you can ask that. Okay. So yeah, let's start with the activity questions. Okay. So the first question says that which of the following code will throw an error? So yeah, from SQL import SVM. So this one is correct. I mean, yeah, we can import the SVM API. And in the SVM API, we have SVC. Okay. So yeah, here the first code is correct, and the third one, like from sklearn.svm import SVC, that is also correct. So it's in simple API questions. Exactly, we can refer sklearn library. Then which keyword parameter used to set the regularization parameter in svm.svc? So C is the parameter which controls, which is called as a regularization parameter, which is helping you to control the, I would say, your margin. Okay. So yeah, which of the following module of sklearn contains the API confusion matrix? Okay. So yeah, that's, I mean, you have used many times.
Matrix.
Yeah, sklearn or matrix. Yeah. I would highly appreciate if you guys also speak, because only two people are there. So yeah. So yeah, what does the method svc.score returns? I mean, it's just simply as you know, like in the all the, I would say, all the regression model, when you type the score, no, it by default it returns the R2 score, and
Uh,
in, yeah, that's true. And all the classification model, what does it return?
Accuracy.
Yeah, accuracy, exactly. Okay, so yeah, that is true. Then the fifth question it is asking, like, consider the following code for the classification. Like here the pipeline is created where they have used as scale standard scale linear SBC, and where C is kept as 100. So it leads to, if this leads to the overfitting, then which of the following value may overcome the problem of overfitting? So we have to avoid the overfitting. So as you know that higher the value of C, if the C's value is high, what will happen? I mean, any idea? Uh, See, the more the value of C, more it is called as hard margin. Okay, so when you reduce the C value, the margin will be means it is called as soft margin. So as you increase the C value, obviously it will lead to the overfitting. So yeah, that's why it is called as, I mean, to avoid the overfitting, you have to reduce the C value. So yeah, from 110, yes, from C is currently it is 100, so obviously reduce it, something like that, C equals 10. Okay, and if you will reduce further, then it may come like a, it may lead to underfitting. Okay, that's why. SVM classifier do not output probability for each class. Yeah, that's true. I mean, yeah, can you say any reason? Yeah. So basically, it's a discriminative classifier. It's not a generative classifier. So in generative classifier, you, what you do is basically you create the joint distribution table, and yeah, from there you calculate all those things. Okay. So can you say like what is, which kind of model this one is? Which kind of classifier is logistic regression classifier? Whether is it discriminative or generative?
The discriminator.
Yeah, that's true. That is also a discriminative model. Okay. So yeah, so can you say, since obviously we have very less content, so obviously I'll try to, since you have come here, so obviously I'll try to give some extra information or something like that. So can you say what is the advantage of discriminative classifier? So and what is the advantage of generative classifier or disadvantage of generative classifier? Something. So two basic advantage I would tell you about the discriminative. Like in the discriminative, you need lesser data. Okay, even with the lesser data also it will work. And yeah, the computation time will be lesser in discriminative model. Okay, so these two things are there. I mean advantage with the discriminative model. Okay, so yeah, it's okay. Which of the following code may be an alternate way, maybe an alternate way to save to the same code? Yeah. So here what they have written is they have written linear SVC. So since they have already mentioned the since in this linear SVC it is by default kernel will be linear. Yeah. So here yeah we have to keep C equals 1 and yeah kernel equals to 1. Kernel is equal linear. So yeah, this one is the alternate code for this one. Okay, so what will be the following code implement? Okay, so what they are doing is like they are just importing the they are creating the pipeline by keeping the degree equals 3, then they are scaling the data using standard scaler, then they are using linear SVC. Okay, so which one would be the correct option?
It's the last one.
Yeah, so basically it will transform the training data to degree 3, and then it will normalize the transform data using standard scaler, and then it will feed the data using SVM. Okay, so yeah, the last option is the correct one. Okay, in this ninth question, they are asking consider the following code, where they have said that make a pipeline and yeah, use the standard scalar in the pipeline first, and then yeah, in the step 2 use SVC, where they have kept kernel equals poly. So what will be the degree of the polynomial kernel function? Can anyone say? So actually by default it is 3. Okay, so that's why we can say that it would be 3. Okay, let's see the scalar library also. So yeah, let's go through this table. So see, the by default the degree is 3 only. Okay, somewhere I have mentioned. Yeah, here only. So degree degree of the polynomial kernel function ignored by all the kernels. So this degree is particularly this degree will be the work only in case of if it is kept as a poly. Okay. So by default it is 3. So that's why they have written as 3. So this Excel library is visible, no? Hello.
Yes, yes.
Yes, sir.
Hello.
Yes, sir. Visible.
Yeah, it is visible.
Yeah, thanks. So yeah, that's why just keep it 3. Right? So it will be 3 only. What is the default value of regularization parameter used in SVC classifier? It's a 1. Okay. So yeah, you can mark as it as a 1. Okay. For a support vector machine model, this question is incomplete. I mean, yeah, something is missing in this question. Okay. Yeah. X1 something. Okay. So which of the following method is used to get the indices of support vector? For to get the indices of support vector, we use the dot support. Okay. Yeah. So let's see here. Mm, yeah. Dot support indices of support vectors. Okay. So yeah, that's true. Okay. Which of the following methods is used to get the number of support vector? To get the number of support, yeah, we use the n support. Okay. So you would have seen like the most of the cases when we write or it is written in the scalar something like a n underscore support. I mean where but this let's say train test split also there we use a train underscore test something like underscore split. I mean yeah to avoid the I mean instead of putting space since they put this one underscore we use in the programming usually. Okay, just extra something I'm speaking. Yeah, it's okay. So from in this just see this code from SQL and import SVM, then CLF SVM dot new SVC, CLF dot fit x comma where x and y are the feature matrix and label vector respectively. Which kernel is used in the Evo classification? Okay, so which kernel is used here? I mean, can you say?
Sir, RBF.
Yeah, that's true. RBF is used here. So which keyword parameter is used in new SVC to set an upper bound on the fraction of margin errors and a lower bound of the fraction of support vectors? Okay. So which keyword parameter used? I think no is used, no? To set an up, yeah. No is used here. Okay. So in this one, like consider the following scatter plot of 4 different data sets. So which will be the classified which data will be classified better using Gaussian RBF kernel? So which one do you think?
The second one.
Second one, no, it's RBF. So it's something like radial.
Yes. First one.
Yeah, first one. So basically, just put a, I mean, circle. So just think like which of the data set can be easily separable using that circle. Okay, something like that. Because what it does is like it just the main function of kernel is to just put it in the higher dimension, and yeah, then separate it using some hyperplane. Okay. So are you able to visualize this or I should show some figures and all? Yeah, okay. If you want, then I can at the end I can show the figures. Okay. So one question two questions I haven't yeah, but yeah, that's true. So one question is wrong here. I mean this one we have to modify this one 11th. Okay. Still something is missing in this question. So yeah, let's go to the question 8.2. Yeah. So first question says, suppose that you want to classify the MNIST data set using linear SVM. What will be the missing attribute in the following course? So what they have done is like they haven't mentioned like which attribute, what will be the missing attributes. So first thing is that it's not an attribute. So yeah, that's wrong. But it's okay. Yeah. So here we have to use this one. I mean, see, since kernel equals yeah. Which option? Hello. Which one you said?
That one only, SVC.
Yeah, SVC is correct because kernel equals linear is already given here. So obviously linear SVC won't be there. So yeah, SVC we can use. Okay. So which of the following parameter in SVC controls the size of the radial basis function kernel? So which one do you think that controls the radial basis function? It is nothing but RBF only. mean, yeah, the full form they have written here, LBC's function. Okay.
Uh,
RPF. So yeah, correct. Gamma controls the radius of that one. Usually we set it to gammas, we set it as a auto because we don't want, I mean, we do not put that, yeah, keep this much radius only. So based on the data, the algorithm will select the best radius. Okay. So in the third one, we have imported the dataset MNIST. Okay, it's okay. I mean, it's completely dependent on that. What is the shape you got from, like in which shape the data is kept. So I think, yeah, it was something
first
like
one.
first one. Okay, yeah, I don't remember because I whether they have
It is the
60,000
first
or
one.
50,000. Yeah.
60,000.
Okay. Yeah. So what will the following code implement? I mean, the first step you have written you have created the pipeline. Where first you have kept many in max scalar, then you have used the as we say classifier. Then you use the fit the model, then you calculated the score. So yeah, since the score is calculated and it's a classification model, so yeah, it will give you the accuracy. So only first and fourth option is the accuracy, and which is learned using non-linear as well linear. So since we are seeing that, yeah, it's a linear one, so yeah, the extent which is learned using linear as well. Okay. So in the fifth question, yeah, that is it is written as wrong. I mean, first option is saying exactly 4 samples of digit 4 are classified as of digit 0. So true level is 4 and only 0 levels are classified as uh, digit 0. Okay. But in case of 5, yeah, 4 levels are classified as 4, yeah, 4 levels of digit 5 is classified as level 0. Okay. In case of digit 5. Okay. So I think, yeah, it should be something like exactly 5 samples of digit 4 are classified as of digit 0. Okay. So let's see the second option. Exactly 2 samples of digit 4 are classified as of digit 0. 2 samples. I mean, it's a 0. So yeah, exactly 182 samples of digit 3 are misclassified. So let's say, I mean, there are 182, I mean, the true level of, I mean, 182 is the correctly classified as digit 3. We are able to see here. Okay, I mean correctly predicted. So third option says exactly 182 samples of digit 3 are misclassified. That's wrong. So let's see the exactly 25 samples of digit 3 are misclassified. So we are seeing that here that, yeah, 182 samples are correctly classified. 15, 22, 24, 25. So 25 is there. Okay, I mean, yeah, these are the pieces which was not predicted accurately as 3. Okay, so this one is predicted, one piece was predicted as 0, one was predicted as 1, 6 was I mean 6 digit was predicted as 2. Okay, something like that. Okay, so it's okay. So fill the missing attributes. I mean, again, it's a this one only. I mean, which one you think, like, what is RPF? So it's nothing but kernel. I mean, you have to mention here kernel. Okay, because the RPF is not a coefficient of classes. Okay, so yeah, these were the questions in yeah, activity questions. Yeah, let's discuss the practice. I mean, yeah, practice questions. Okay, so is it visible? See, you can, yeah, you guys are here, and whenever you feel any doubt, no, please ask. Okay, because yeah, only 2 people are there, so yeah, obviously, it's just that I'm for others' sake, yeah, I'm just covering this. I mean, each question so that when they will refer, yeah. So yeah, right. First question is saying that write a function compute score x train x y train x test y test to do the following on the iris dataset. So write your code keeping in mind, yeah, split the iris dataset into train and test. Instead of reading the question, I'll directly, yeah, go through the solution. Okay, because yeah. So first sentence is, yeah, we are importing each and everything. So JSON or these files, these imports are not needed here. I mean, yeah, in MLT, yeah, we need this one because yeah, there we have to put it on the discourse. I mean, to the portal. So that, yeah, it's okay. I mean, yeah. So we imported the iris data set, and yeah, we imported the trend test split. Okay. So we have to write the function compute score, something like that. Okay. So in the this line, what we did that we did the trend test split. kept we kept here our test size as 0.3. Okay. So in this one, I think no of you has doubt. So have you gone through that post? I mean, where why we when we take keep as a test train size is 0.7 and test size is 0.3, both of them don't give the same answer. I mean, there was one post on discourse related to that. Hello.
Yeah, I've seen that
Yes, sir.
post.
Yeah.
Yeah. Yeah. Actually, yeah. Even I also got to know about this one. I mean, yeah. Recently, only. I mean, after the discussion of the week 7 questions only, I also searched what is the reason. I mean, yeah. So yeah. So second, in this question, yeah, let's see. I mean, the what we have done is like we created the model. We kept kernel as RBF, C equals 20, gamma equals auto. Okay. Then we simply fit the model and yeah, we return the score. So instead of yeah, what we have done here is like we converted it into something like in the function format. Thing else is there. So yeah, I think this is now we can see the code time is split the data 70-30 ratio. Import as VM as a model, kernel as RBF, regression parameter as 20, gamma is auto. That is what we have done here. I mean, okay. So yeah, one question post just now, just yeah, few hours back I saw like I haven't replied there. So they have said that yeah, can we put here as shuffle equals true? I mean shuffle equals false. It will be exactly equal to this one. I mean, if we put shuffle equals false, no, it will be exactly equal to normal split. I mean, we do the normal split. No, I mean, from this one to like, let's say like we have 100 samples. So we are keeping like around 80 sample size train. We do manually. No, I mean, just splitting the data, slicing operation. So it would be same. Just this shuffle equals true. By default, it is true only. So that's why we get every time when you will use the trend split node, you will get different samples. Okay. So that's why I mean, yeah, since you haven't set it, so it's yeah, by default it is true. Okay. So yeah, that is one thing I would say. Yeah. Question one is
One doubt regarding the random state parameter. So if you set the random seed as we have done this in this code, like
yeah.
now in every time you need a like a random number, does it generate the same number or the next number in the series?
No, it is nothing like that. I mean, you can put any numbers. It's just a see. Yeah. Hello.
Seed is fine. So for example, now when we use train test split, it will generate numbers, random numbers, right?
Okay. Yeah, that's true. Because we have kept that shuffle equals by default it is shuffle equals false.
Yes. So it will generate some random numbers. Now, for example, let's say we are using some other function which generate random numbers.
Okay, okay. Yeah, it will also generate because by default it's shuffle equals true. I just mistakenly saw that.
No. So let me complete my question.
Oh yeah, yeah.
So
Sure.
let's say like we're using another function which uses random number generator. Does it give the same series of random numbers which this function generated, or the next in line?
Just repeat your last sentence.
So when we set a seed equal to 42, you are initializing a random number generator, right?
Okay.
And when you call like train test split, you will get a series of random numbers, for example.
Yes.
Yes. Now let's say I'm calling train test split again.
Yeah.
Will I get the same set of random numbers, or like the next few random numbers from the generator?
I think you will get different random number generated, different random number. I also need to cross check that. I would definitely say, but yeah, I think you will get. It's not dependent on this thing. I mean, this number. It's just that after setting any random seed, no, you will get the same answer every time. I mean, yeah. But yeah, obviously, I also need to cross check this one. What do you said? So basically, did you mean that here also random np dot random dot set, if here it is set as 42, then here also it will work something like as 42 only.
No. My question is really, so when you set seed, we're basically initializing some random number generator, right?
Yeah.
Now we keep on using different functions which need like random numbers.
That's true.
like does the sequence of random numbers which are generated, are they the same every different time we call a function, or like is it from the subsequent uh, random numbers from the series of random numbers with the C42?
I think it would be same. I mean, once you are keeping that random seed here 42, then let's say, I mean, here if it is giving that 32 something or 31 something like that, it's okay. Just check right now. Only we can check.
Ah, I will, sure.
So let's continue. This one is connected. Okay. This one is connected now. Yeah. So we know that in the trend split we have the option of randoms. Yeah, random state. No. So I think if it will set the random state every time, some different value, then yeah, we give the different statement. Okay. Let's see. It is giving something like this one. 4.8. Let's run it away. Five point six, 2.5, 3.9.
I got the answer. Thank you.
Yeah, that is what I'm saying. Yeah. Every time you will get the different. I mean, it doesn't depend. This one is something different and this one is something different. Let's do. See, this time it will give you this one. Yeah, it's okay. And let's say here random state something like. Yeah, so every time you will get the different. Okay. So was there your did you got your answer or what?
Yes, I did. Thank you.
Yeah. So actually this seed is not for this one. I mean, this seed we kept here. Actually, when we put it on that, no, I mean the portal, no, configure the questions on the portal, no, in MLT. So there we need this one. I mean, due to this one only we change the every time. I mean, we change this random seed value and yeah, we get the different answer. And it is used to check your answer whether it's correct or not. I mean, different private and public test cases are there, no? It works based on this one only. So yeah. So first question is quite clear. Okay, in the second question, in question one, apply a pipeline containing a min max scalar function called scalar and svm.sbc called classifier with the parameter kernel equals linear decision bound decision function shape equals OVR c equals 1 class weight equals none calculate the precision value and difference. So it is simple, plain and simple code. I mean, just create the pipeline as they said. I mean, so just write each and everything, and yeah, just fit it. And after the fit, just calculate the precision score, just create the just calculate the recall score, F1 score. So yeah, they have printed that. Okay, so in the third question, import the iris dataset and drop the rows where class equals iris versus color. Okay, apply pipeline containing a minimax scalar function called scalar and svm.sbc called classifier. Split the iris data into 50-50 ratio. Ideally, we should not do that. I mean, 50% data for training and 50% data for testing. So yeah, with random set equals 0, make the correct recall value from the given option. Okay. So yeah, let's yeah, here we have imported all the matrix, yeah, all the APIs. Okay. So yeah, they are after putting all the APIs. Yeah, we just imported this data set, iris data set, and yeah, we gave the name of the iris data set here. Okay, so since header is equals to none, so yeah, that's why we have to give the name of columns. Otherwise, so what will happen? I mean, if I don't give that header name, so have you tried this? I mean, because in one of the question actually what has happened, yeah, or you can keep it in your mind, because when you want to give that header name, no. So I'll just so. Okay, I can run this one. So let's leave this PDF. Okay. So I'm just simply, yeah, see, this is what will happen. I mean, it will take your first row as a header. Okay. So obviously you are losing one row of the data. It won't affect your model much, but here when we create some OPE question or some question, no, here it will affect your, if you will calculate the, if you will ask you to give me the intercept value, no, then it will get affected. I mean, intercept value gets in. I mean, hardly 200, 148 rows are there. It's not like we have, I mean, yeah, like in lakhs or in thousands. So yeah, it will affect your this one. I mean, affect your intercept value. So yeah, be careful. So just see that, yeah, whether first, I mean, this column is really a column name or not. If it is not, then obviously every time put header equals and none. Okay, and you can set your I would say, yeah, set your values. I mean, set your feature names. Still, it won't give you the feature names, but yeah. Now this 5.1 comes together. Now you have 150, yeah, 150 rows. Okay, yeah, that is what. I mean, these things people does them. People do the mistakes. I mean, we don't cover these things, but yeah, it's a basic thing. But since we have time today, so yeah. So data equals df index names equal data. Yeah. So what we have to do is in the question they are saying that we have to remove all the rows where the class equals iris vertical. Okay. So what we have done here is, so we have just checked that, yeah, data equals data class, this column class column, and here we are noting down the index. We are saving the index of all the classes of iris versicolor. Okay, so we saved it in the index dot names. Okay, and we simply drop that. Okay, so can anyone explain what in place equals true or false does? What this attribute does?
So if we
Yeah.
don't use in
Or
place
it
equal
creates a
to
copy.
true, a copy data frame is created. In this one, it happens in this data frame only.
Yeah, yeah. So if we will set it as a false, no, say, yeah, then we have to save this in some new data set. Okay. I mean, yeah, in some new variable, I would say. And if it is in place equals true is there, so yeah, this change will happen in this data only. I mean, yeah, permanent damage, something like that. You can say, yeah, permanent changes, or yeah, temporary changes you want. So yeah, that is controlled by this one. So yeah, x comma y. So what we are doing here is we are keeping all the rows and yeah, all the column till -1. I mean, yeah, just we are removing the last, we are ignoring the last column, and yeah, all other column we are keeping here. So in the y, we are taking all the we are taking just particularly the last column. Okay. So yeah, it is something like that we are doing here. We are saving it in x. We are splitting it in x and y. Then yeah, we use the trend test split since it was mentioned. I like test size is 0.5. Then yeah, random state equals 0. So yeah, we check the shape of the data set, our shape of our data set. Yeah, and after that, yeah, that's okay. So yeah, we are considering. So basically, we are considering just two variables. I mean, just two features only. Is it? Is it mentioned in the question or what? Left put that is our data set and drop the rows where color equals split the arrays data set with random. So mark the correct recall value from the given option. So that is what they are doing. I mean, yeah. So x dot cp is, they are basically just simply just ignoring the other two. I mean, yeah, these two maybe they are yeah, they are ignoring these two. And after that, what they are doing, I mean, in the second row, okay, so we haven't used this before. I mean, yeah, let's see in the second question what they are, we are creating the, in this one only, in the second step, like we created the minimax scalar, we created a pipeline where we have kept a minimax scalar, then SVC, and which data we have used here. So that is what I wanted. Yeah, exchange. So yeah, exchange is normally, I mean, yeah, this 50 comma 4 is only. I mean, they would be trying something else here. So, but yeah, finally they have used the exchange only. So exchange is something, nothing but yeah, the shape of exchange is 50 comma 4. So yeah, they are not, they haven't ignored any columns. Okay, yeah, based on that, they predicted this. Okay, so yeah, and after that, they got the precision recall values. Yeah. In the fourth question, they are asking like write the function compute score xtrain, ytrain, xtest, ytest to do the following on the iris dataset. Okay. Write the these things you can do this one. Yeah. Consider loss function equal this one. I mean all same question only. Just nothing is changing. The same question, exactly same question, but just now you I have to mention the loss value and penalty is you will get the answer. Any issues, any question? Because that's just a plain and simple question. So yeah, in the fifth question, write a function hyperparameter search which accepts the kernel regression parameter as inputs and return the average score of the model with the below mentioned hyperparameters. Okay. So in the first step, we are splitting the data set. Then in the second step, we are writing kernels as a linear and RVF regression equals C equals 5, 10, 100. Okay. Yeah. So again, we imported the data set, we splitted it using the mentioned value. I mean, yeah, 70 in 17:30 ratio. And then, yeah, we kept random state as 42. Yeah, these things are mentioned. Yeah. And after that, yeah, we have created the function. And what we are doing is, okay, so like this, they are doing. Yeah, you can use the grid sets also, no? I mean, yeah. But it's okay. I mean, what they have done here is, I mean, they have created a hyperparameter. They have created the function and average score they have kept for I in kernels, for J in C. Okay, so to go through the all the values. So yeah, this can be also an alternate way to just do that grid search CV. Okay, so yeah, they are just doing they are saving all the scores. Okay, cross validation scores, and after that average score they are whatever the average score they are getting, they are appending in this list. Okay, and after that what they are doing is they are keeping that they are giving output as a max score. So it looks like a multi question, nothing. Here we have libraries like grid search, so yeah, they can calculate, they can do this themselves on there. Okay, so yeah, these were the questions which was supposed to get covered, the practice question of week 8. So yeah, nothing else is left. Any other doubt or anything else you can say? Otherwise, if you want, I can teach something some other things also. Hello. Okay, so yeah, I'll start asking questions. Yeah, please say.
So can you go over the pipeline bit again?
Code with Python.
No, the pipeline bit again. Can you go over it?
Yeah, this one.
Yeah. Can we discuss this part?
Yeah. So here in the Python, what we are doing is in the first step we are applying the min-max scalar. Okay, in the second step we are saving that svm.svc. I mean, we are simply just saving that our classifier. Okay, we are saving our classifier in the second step. So here they have mentioned that we have to use kernel equals linear decision function shape as OVR C equals 1 class weight equals 1. So these things.
Sir, why the choice? Why these choices? Because that is very important not to understand why these choices.
So it is something like I would say, yeah, they have mentioned something like that. Nothing like this. And if you want to change, if you want to change, then you can change. That's why these are the parameters. I mean, we have kernels because other values also. So nothing specific I'm able to see right now. Just they have mentioned.
So yeah, that is my problem with the assignments also, sir. All the solutions are pre-given. For example, I'm exactly told what I'm supposed to do, but in real life I'll be facing problems that I have to solve by myself. So the why is very important, no sir. So
Yeah.
why are we using SVC here, and why not other things?
Yeah. So the thing is, I would say, see, the old models are, these are the very old models. I mean, yeah, support vector classifier, linear regression, logistic regression. Nowadays, obviously, time to time the models are getting improved. And
Mhm.
what you have to do here, no, I mean, personally, in this these things, it completely depends on the data set. No one can tell
Okay.
you directly. I mean, you can't keep this one. Yeah, this one is a hard and fast one. Every time, just you have to simply just check that your score. I mean, which score you would be more accurate according to your model, and you have to just check that after by treating these things. I mean, if you are not getting, or you, since if you are not able to visualize your data set, I mean, see, as we were
Mhm.
as we were able to as you saw this one data set now. That's, I mean, if you said this one, just see. Uh, okay, so if data set is something like this, then obviously RBF is a good one. I mean, RBF can separate these two. Okay, so like that only. I mean, it completely depends on your data set. If let's say here
RBF is
radial basis function. Okay, so it
okay.
is
I
something
don't
like
think we've been taught this, sir.
I mean, we haven't get in this one only we use that. I mean, there you have to set that RBF kernel in kernel or GAM. Yeah, okay. So in that you have to save that. So that is what I'm saying. I mean, it completely depends on your data set. So what I am trying to say convey, you know, it these all these things, it depends on the data set. I mean, if you don't understand, I mean, if you have the understanding of your data set, then you can set that particular value, or otherwise just change these things. Okay, and just see like what is the effect that it is going to create on your model. Okay, so if your data set is linear, then obviously kernel equals linear is a good thing. I mean, so you are getting
No, no. So,
so
so how do you see if your data set is linear or radial? Or...
yeah. So it would be see, that is what in the practical life it is not possible to see, because if you have data, I mean, there are two variables are there, then you will be able to plot that. Okay, then you will be able to plot that properly. Okay, otherwise you won't be able to plot that. Let me share one PDF I have, one collab I have just wait. Okay. I mean, you see, I would tell you the one thing. I mean, it completely depends on that part. So
Yes, sir. So I'd like to understand. So if we are faced with a problem, how am I supposed to decide which model to use? So I can decide from the label that if I'm supposed to do regression or classification. But what I've noticed is that sometimes the label is also ordinal in nature.
okay,
So
yeah.
how would you deal with something like that? Or even like you were saying, can I find out through EDA as to which model I'm supposed to use?
Only EDA won't help you that much, but yeah, definitely EDA will give you the direction. I mean, and usually what happens nowadays, no, I mean, just I'm telling you the simple ways. It
Mhm.
all these things depends on the like how many outliers are there. With then, if you have outliers, then you, which one you will use. Usually, not nowadays what people do is the basic thing is like you just using linear regression. This one people use because like you get the interpretation here. No, I mean, if some particular feature is getting higher weightage, then obviously you are able to understand that yeah, this feature is important, that feature is important. So linear regression, logistic regression, people just use that one to get the basic idea of the model. I mean, basic idea of the data set and all. Okay, and yeah, we
Okay.
feature importance and all. The people get the idea, and after that they use the model like gradient boost, XZ boost. Okay, yeah, these things are there. And apart from this also, like nowadays we have deep learning. But yeah, the main issue with deep learning is that yeah, we need more data for deep learning. Okay, so yeah, that is also one thing. Okay, and here usually yeah, you have to go through the, I mean, there are yeah, these parameters, there are few parameters which work with particular cases also only. I mean, when you are just as you see, no, when you have to use the gamma, then you can't use this one and that one. These things are there. I mean, when you are using the poly, then only you have to set the degree. Otherwise, degree doesn't have degree. Then it doesn't give any sense if you set the degree. Okay, so these things are there.
I didn't get the point about gamma and the degree, sir.
Okay, so what I'm saying here is, just see, in the library. So what is happening here? See, let's say, I mean, see here. See, kernel value. I mean, there are different kind of kernels. As I talked about this RVF kernel, no? So it is there. I mean, it's a kernel only. Okay. So what is what I was saying? No, specify the kernel type to be used in the. If none is given, it is callable. Callable is. Okay. So yeah, here I was saying that if we have parameters, let's say that a degree also. Okay. But if we are not setting that this one, I mean, if we are not setting kernel equals polynomial, then we don't have to set this degree. So
Right.
yeah. So yeah, that is what I'm saying. That I mean, there are few parameters. I like a few parameters are in logistic regression. Also, you would have seen that when you have to use set that a different method were there. There no. I mean, what I would say, yeah, there are few cases. I mean, yeah, this let's say what I want to convey is like let's say linear and degree equals 3. These two combination doesn't work. Okay,
Right.
poly and degree equals 3 is working. Okay, I mean, whenever you have to set this, whenever you are setting this to poly, then you have to set degree, some degree values. Okay, so this combination is working. So that is what I'm conveying here. So there are few combinations which won't work. Okay.
Sir, would you say that there are some cases where you just wouldn't use some models? Is there
Yeah,
things like that?
yeah, it you can say that something like this. See, let's say if you have to work on the recommendation system. Okay, so yeah,
Okay.
yeah, there are particular models like, I mean, yeah, KNN works well, or K-means, yeah, K-means clustering also you can do, and yeah, these things works well. Okay, so yeah, these things are there. I mean, like say, let's say the basic advantage of SVC is something like, so it is robust to outliers. I mean, let's see. Obviously, logistic regression is also robust to all the descriptive models are robust to outliers, but still, I would tell you that this one SVC is more robust to the outliers. So what is does is like here, let's say we have this data set, okay, something like this, okay. So and we have few points. I'm just creating this data set, okay. So and what will happen in SVC is something. So in SVC, you will create a, I would say, yeah, just short. It's okay.
Yeah, we create a separating path.
Yeah. So yeah, this one with along with the margin, something like that. Okay.
Right.
Just
Right.
yeah. So what is happening here is it is robust to that. I mean, if some value, some cross is here, then it is not affecting your this one. I mean,
Model.
decision
Yes.
boundary.
Yes.
Decision boundary.
Correct.
And yeah, if some values here, then also like it is dependent on this one. I mean, the closest values, whatever the
Right. Right.
closest green value and red value is there. So obviously, if you are able to see that, if you are able to visualize in your idea that you have so many outliers, then obviously logistic SVC is better than your logistic regression. Obviously, SVC will give you the better result if you compare it to the logistic regression, because it won't get affected that much uh, with the if you have outliers. So, okay, but these things you can check by just by checking your accuracy of your model, something like that. That's why I'm saying that, yeah, so that's why these are the evaluation matrices you can check. And usually that what we do is it's plain and simple. I mean, we just create a matter, we create a function, we just in that function only we can write that yeah, just give the score of logistic regression, give the score of SVC, give the score so in the just one go we get the all the scores. Okay, so by seeing
Okay.
that
All
we
this
can compare.
goes right.
Yeah,
Right.
yeah, these are the things are only like these are the things only which you have to do. Otherwise the ML model, the automl is coming. So why it is, so these are the reasons. That's why, I mean, people are a few people are saying that yeah, automl won't work. I mean, still people we need people. to visualize, I mean, to understand what
No,
this.
sir, this actually sort of convinced me that AutoML would work because I think if it was just about finding out outliers to reason out models, even basic calculation can tell you the number of outliers. So
Yeah.
maybe AutoML would work, no?
So no, outliers is not the only thing. I mean, that is what I'm saying. That it's. I just gave you the example. Let's say based on the outliers only, or who is saying that only accuracy can be a good criteria to check that whether your model is
Right.
good or not. So no one is saying that.
Mhm.
KPI can be anything. I mean, no one can.
Right.
No one can say that accuracy is the best KPI every time. So no one is saying that. Okay. And that is what I mean. Let's say that you have to check that in our courses also. Let's say you have to decide like whether some person is good or not. So you have to decide the KPIs here also. So you
Right.
can. So that is the job. Obviously it will reduce the task of data scientist. That's true, but ultimately you are the person who have to convert that problem into the data science problem. That is the first thing. I mean, the biggest problem in the
Right.
data scientist is that you have to convert it into a sub problem. Okay, just
Right.
and then also you have to convert that data set which can be
Uh-huh.
used. I mean, which features you want. I mean, let's say I am asking you to just um, predict someone's score. I mean, predict whether someone what will be his score or her score in the
Right.
fine
Right.
end sem. So you just created the model question. This
Okay.
AutoML can't create that question. Okay, then again you have to decide like what are the datas we need. I mean, what are the features which are important and what are the features which can be useful. These things you have to decide. And again, after this thing, this interpretation, then
Uh-huh.
you have to go through. Then you have to convey to the person also. Okay, because see, ultimately, if you are going to solve some market problem, no, then your
Mhm.
client would want to know that what you did and why you are saying that this one is important. Okay, that questions also you have to answer. So ultimately, there are many black box models. Okay, so those model works very well. I mean, so I mean, even the deep learning has come. Still, people use it. I mean, still most of people uses that these things. I mean, these ML models first.
Right.
Why?
Right.
Because here we get the interpretation. These are not black box models. Okay, these are
But
not
sir,
black. Yeah.
one more problem that I'm concerned with is that, like you said, what if we had got the data source only wrong? Then all the claims are baseless, no?
Yeah, that is true. That is what I'm saying. All these things you have to decide. I mean, yeah, uh, we have lots of data, lots of data, but still why we are not able to convert them into problem. So in the nowadays, like Indian government is also focusing on collecting the data. I mean,
Right.
in each these Anganwadis and all. I mean, in the local level, you say that at the village level and all, they are trying to collect the data. Earlier, we had lots of data in the I mean, the registered and all. Yeah, they used to keep it on the they used to keep as a hard copy, but those are useless. No one can use that. I mean, what will you do? Okay,
Right.
so so that's why I mean the people are focusing on to collect focusing on collecting the data, and that too I mean useful data, not I mean garbage. So as they say, garbage in
What
garbage
would
out.
you call garbage, sir? Something that's not correlated with the output, is it?
Yeah, that is what I'm saying. I mean, which is
But even that also you can identify with AutoML, no? So if something was consistently not correlated with why I could remove it.
uh, yeah the one thing you can say that that can be, but see, let's say like we have to decide the selling of the ice cream. Okay, let's say take the
Okay.
example
Okay.
of selling of the ice cream. I'm saying that for that I'm saying that what is the what people is wearing, what this is the I mean completely random data. Just think
Right,
like
right. What people are wearing.
colored
Oh, yes.
colored of shirt. It is not dependent. Obviously the algorithm will will calculate something like that. Anything. I mean, obviously when you are giving to it to train the model, they will forcefully they will try to get some relation from that. Okay.
So I was reading somewhere that a model like random forest and all will automatically be able to remove unrelated features. Why is that claim made, sir?
They are able to do that. I mean, but still that is what I'm saying. I mean, you can say that random forest and all those are also just your black box model only. Interpretation is not that much. So again, there also
you can't get a feature importance from random forest. I noticed that. So
yeah. Yeah, that is what I'm saying. I mean, after that random forest, I mean, just see, I am asking about to you the ice cream sale. Okay. And you after that, you just trained your model using random forest, and you are saying that, yeah, these things are very important. I mean, you just said that, yeah, this this third color is very important. So I will definitely ask you why. I mean, as a client, I will definitely ask you why. Okay. So you should have some answers. I mean, or yeah, you just or something like that. I said that, to you that yeah, this you have to focus on the third color, and let's say soil, let's say yeah, soil color also, or something. I mean, anything random or shoe color. Okay. So these things are very important. You are saying me, you train the model, and I as a client I will say why these two, why I will focus on these two. So definitely, I mean, basically data science is what I mean. You have to solve some business problem, and the business guy, that guy doesn't know the data science. That you just trained, you came after training this model, and you are saying that yeah, we have to pull lakhs of rupees, crores of rupees. Okay, but why? I mean, just by saying that, just you are saying that's why I will put the this much amount. That's not fair.
Right.
Yeah.
Right. Okay. So, sir, the majority of real products getting produced are in NLP and computer vision, is it?
Yeah, nowadays, yeah, most of the yeah, I think these are the two sectors. I mean, which is just like booming. I mean, the bigger problem. See, NLP deserves that respect, because what is happening here? No, like all the things are currently in. I mean, we have lots of data. We need a lot of data cleaning and all. So for all those things, we need NLP. Okay, so that's why. I mean, the most and as you know that this one, computer vision also. I mean, we have lots of videos and all. So these two things are after that. I would say that after your these basic courses, definitely just try to go in one of the sites. I mean, just to get a specialization in NLP or computer vision. That I would definitely say. I mean, yeah, obviously after this you have to learn the deep learning, and yeah, then you have NLP, computer vision, reinforcement learning. These things are, but obviously I will definitely tell you to just start getting a specialization in these two. I mean, lot of job opportunity and all those things are there.
Right. Sir, if deep learning is not explainable, then why the focus on deep learning, sir? Is it just because the results are better or something?
Yeah. Exactly, that is the reason. Results are better, much better, I would say.
But I don't know, does that make it good enough for use in the industry? Because suppose if I was deciding if I should give people loans basis this, and I did not even understand if the model was biased in some way against a gender or a community, how does this work?
That's why that is what I'm saying. That's why still these models, these basic ML models are still in the industry. Okay, so it's not like that people doesn't train these, people doesn't use this one. So okay, basically they start from this one only. Okay, to get the interpretation, to understand the data set properly in much better way. So that's why these ML models are there. Still, I mean, recently I was like, yesterday or day before yesterday, I was reading a post on LinkedIn. A guy was a like data scientist. He has been working like more than 20 years. So he has mentioned few points related to data science. I mean, there also he mentioned that yeah, still in the industry, most of the like sklearn is the most convenient library for us. Like deep learning is not that much in use, and some other points were also there. I mean, yeah, I don't remember. I'm not able to recollect those points now, but yeah, I was quietly convinced with his points. I mean, yeah, those points.
Right.
Yeah,
But there is also utility in automation, right? So it's not just insights. You can also use ML to automate things, no?
that's true. That's true. And also, as you said, no, I'm not completely denying that AutoML is not coming. AutoML is not reducing the. Obviously, it will reduce. And as I'm saying, no, that obviously this data cleaning, the most of the 80% of your time goes in this one. So obviously, data cleaning can be done automatically.
Right.
These things,
Yes.
yeah, these things will get automated. I mean, the interpretation part, all these things need human touch. But yeah, there are many. I mean, just you have to just, as you said, no. I mean, just we have to go through that n number of models. I mean, I just created one function and it will run all the models. Okay, so these things can be automated. So yeah, automation is also working. But yeah, as I said, yeah, there are few things which only human can do. Interpretation and all those business, yeah, business understanding that machine can't do. So yeah, these things you have to do. And yeah,
Right. Right.
yeah. So yeah, so basically, like why, one question I would say that why why you need SVC. So have you got this question? I mean, you had this one, logistic regression, then why you need SVC.
Why you need SPC? I don't know. That is an interesting question.
Yeah. So see here, what is happening? Yeah, I'll just try this. So yeah, let's say these things are there. Okay, and here you have, okay, so these things are there. So I asked you, in, let's say you have to train the logistic regression. So logistic regression is anything that which can separate these two. uh, this line is also able to separate that. This line is also able to separate that. This line is also able to separate that. I mean, all the three lines are able to separate these two features. I mean, these two samples. I mean, so are you with me? I mean, did you got
Yes,
my
yes,
point?
yes, sir.
Yeah. So if any point comes around here or something like that, this. So obviously, a different decision boundary will give you the different result. I mean, if this point is there, let's say about this point, this classifier will say that yeah, it's a cross, not circle. Yeah, but this one will say that yeah, this one will also said that this is a cross, but this one will say that yeah, it's a circle, not cross. Okay, so like that. I mean, the different decision boundary will say yeah, the different thing. So we need some more. I mean, we need some margin by which we can say that whether it will, whether it is circle or. Let me try to get that. Okay. So to do that, we came up with the solution that we will keep some margin. I mean, let's say we keep this much margin. Okay. So yeah.
Right.
So we have to select that model which has the longest margin. Okay.
Okay.
Yeah. So that model which has the longest margin, that would, as we see, classifier will give you that model. We will keep that as a decision boundary. I mean, whatever model has the largest margin, no, this
Right.
width is the last. Yeah. SVC classifier will give that, select that as a decision boundary. Okay. So in that one, I will just show one question. So how it is affecting your question. Let's say, so here you have cross. Okay. So again, so you have to create a decision boundary, okay, with the margin. So according to the SBC, yeah, obviously we will select that boundary which has the highest margin. I mean, so this margin depends on the closest value in this side and closest value on that side. Okay, so this one has the highest margin, so it will select this one. But it depends on this one, this line. No, if this line, if you shift here, let's say here, if you shift this one, this line, no, and yeah, I would say yeah, we can keep one circle here. Okay.
Okay.
Yeah, so these are the outliers. I mean, it depends, it won't get that much affected by this line, because since we are looking at the longest margin, no? So this so
I
this one is
didn't
correct.
get that point, sir.
Which one?
No, the point that you just made. So this is a circle which is in the wrong side, right?
Yeah.
And it will still not affect the margin because.
So see, this one is, I would say that, see, this line is on this side, no? So it will affect your model. I mean, obviously it's you have to see that, you have to just ignore this line. I mean, obviously the based on that margin, no, it depends on your margin. That's why you have the parameter c, which controls your model. I mean, controls your this one.
Margins.
Yeah, margins. Yeah, which will control your margin. I mean, whether you have to go with the hard margin or low. This one, hard margin or soft margin. Okay, so if you will go with the soft margin, no, then you will take if you will go with the soft margin, then you will take this one as a inside this margin only. I mean, you will take this sample inside the margin, and you will keep your sample. I mean, keep your decision model something like here, something like this. But if you have to go with the I would say soft margin, hard margin. Sorry, soft margin I just not draw. If you will go with the hard margin, then you will draw your decision boundary somewhere here. I mean, just this one, just this line, and decision, and this one would be your this line, and this one would be your that. I mean, this one has a hard margin. So, do you agree?
Yes, yes.
Yeah. So yeah, this one is a hard margin. I mean, C value is higher. So what you are able to see that still, I mean, just because of this space, yeah, it is a case of overfitting. So
It's a case for and SVC is only for linearly classifiable things.
yeah, only for linearly classifier. So did you have? I mean, so did you got my point or what?
Yes, got it, sir. So the soft margin has some tolerance, so it doesn't overfit, and this one overfits.
Yeah, and it depends on completely on the test data set that which one is better. I mean, let's say that test data set is saying that obviously one thing is that definitely is there that whether if it's overfitting because you are seeing that most of the your zero is here and most of the crosses are here. So if any cross is just close to this one, it will be misclassified. Is it no? If crosses are there just close to this line, but here when you had drawn your decision model somewhere here, then you had high chances that the model will the new sample will be classified accurately.
So yes, the doubt that I have is the margin of error that you have. That is I don't know. That is still where we can permit misclassification. Is it?
Just repeat your last sentence. What is it?
So I'm not able to understand. So like you said, no, if that entire line was a line of crosses, then that would be a lot of points misclassified. So will there be no penalty for that?
Yeah, we have penalty for that. That is also, I mean, in the loss function, loss function, in the loss function, the penalty you give your model penalty only to those samples which is inside this margin. You know that? I mean, have you gone through the loss function of the SVM? So basically, we in the loss function, the penalty is given to the all the samples which is inside this margin. As I said, in this one, this one is this one went on the another side, like when we have soft margin, and this point was opposite side of the line. I mean, inside this margin only. Then this point is this sample is contributing in your loss function, so it is increasing your loss value.
So okay. So when we are doing soft value, although there is misclassification, but it adds to the loss.
Yeah, but that's why your loss value is little higher. That's why your model's accuracy is little low. No, I mean,
but sir, if the loss value is higher, will the model even converge?
Yeah, see that then that is a case of I mean underfitting and overfitting. That again, see what I'm saying is see low value of C, low C, okay, low C, then obviously soft margin, it is a soft margin, okay, soft margin, then it will be a case of underfitting. I mean, if that is too low, okay, I'm just writing about the case of too low, okay, so it will it is if it is too low, okay, then loss will be higher. Okay, so it is the case of LOC. Okay, when your C is increasing, okay, then it is a hard margin and it is overfitting, then loss will be lower because it is overfitting. A loss will be lower on the training data. Okay.
Right. Variance
Yeah.
and bias trade-off.
Yeah.
Right.
Yeah. Bias and variance trade-off. It is like that one. Okay. So yeah, that is the point which I want to convey. And yeah, anything else?
But yes, sir. So one more question that I have is if we just had to do regression and classification, why so many models? So these are distinct models, no? I understood why you needed logistic regression because it helped you get the probability. But can you maybe go through why each of these models came about? Just
See,
over.
it is just like that. In the like older version, we had bulb like yellow bulb. You remember?
Yes, sir.
After that, you came to some CFL. I mean tube light, then CFL, then now LED light. It is just like that. So people are continuously developing some new models, something like that. Okay. So now it see, I have some solution, you have some different solution. It is like just like that only. I mean, we have different solutions. So which will work, which method will work for you, that you have to select. Okay. I mean,
Right.
yeah. So this linear and completed you can see that this one also support vector math. Yeah, this one is also very old model. So yeah, continuously, I mean, tons of new models are getting developed. So why we are reading the whatever the model we have read here in this course? No, these are very old models. I mean, we haven't covered in the course in this course like XGBoost, yeah, gradient boosting, and I mean, yeah, random forest is was covered in this, yeah, in this course. But yeah, there are models like SGBoost, yeah, extreme gradient, yeah, these things are not covered.
So, sir, one more thing that I have a doubt about is so I noticed that when you're trying to encode dates, you do something where you're trying to convert it into cos and sine and all that, trying to make it cyclical so that you can encode the fact that it's moving forward. Can you maybe explain that if it's possible?
Yeah, sorry, I just repeat whatever you said. I didn't get.
Yeah. So, sir, I was going through one of my data sets and we had to encode time in that. So, dates were there. And I noticed that they converted into sine and cos to make it cyclical. So, can you maybe explain that?
Yeah, so why they are converting it to why they are converting into cyclic, something like that you are saying?
Yes, sir.
Yeah. So then only if they won't convert it into the cyclic format, then only you will be see. It is just like the see. Most of the interpretation you want from the date is like which month is something. I mean, see. Let's say we have to decide booking. I mean, this one. Which one is the? I mean, hotel booking platform. This one in the foreign, I would say one is there like where you can book some resort and all. I mean, you can put your house. I mean, just let's say like let's say
Airbnb, is it?
yeah, Airbnb. Yeah, Airbnb. That is what I just yeah. So let's say you have to I have to book one room. Yeah, let's say we have this city, okay, and yeah, we have to see that we are just trying to we were trying to just give the price of that hotel, okay, price of that hotel. So there would be some, I mean, in the some month or some particular season like just summer vacation, okay. So during this month, obviously the sale will increase, so obviously we can increase the price, okay,
Right.
increase the price of the room. So these things will get covered. I mean, if the date is all the dates are new, I mean, let's say that all the dates are different. So obviously your model won't, I mean, for that model it is all the dates are different, so it will take it something like I would say, yeah, something different value, I would say. So it won't get any relation with this one. I mean, it won't give the any relation of price with this date. Are you able to understand? If you will make it cyclic, then only it will think, it will see that, yeah, during this period, yeah, we have the high value of price. Then only your model will cover that.
Right,
Yeah,
right.
yeah.
Yes, sir. And how would you do that? How do you convert it into cyclic?
I mean, it depends on the code and all. Yeah, you will get all these things. I mean, if you want me to do that, I mean, I can share the codes and all, if you will ask on the Discord, or otherwise you can search it. These things are not a big thing. I mean, if you are able to
Right.
convert, see, nowadays I would say, one thing I would definitely say, whenever you are trying to build any model, no,
Uh-huh.
definitely first do a Google search. I would say that let's say, why to write any function, why to invest your a lot of time writing some functions. Okay, so there would be some people who had done that. Definitely, I mean, in 90% cases, no, that function would have someone would have already made. Okay, so just
Right.
import that. Yeah, just Google search and import that. No need to just waste your time and doing, just
Sir,
writing
would
the.
you recommend resources? So, Google search, I'm not sure about the credibility of things very often. So,
Yeah, yeah, that is true, and I can't say anything about that. I mean, everyone just go through the Stack Overflow code, and yeah, just like in the most of the cases, like we just search that go through the Stack Overflow, and yeah, something will work, something will not work. It is like that regarding the code, I would say. And obviously, when you will start practicing on Kaggle competition, when you will start participating on Kaggle competition, yeah,
uh-huh.
when you will start participating in Kaggle competitions, no, those things works. I mean, after that, where you will see that different people's method and all. So before, just for example, I would say, before creating these courses also, like, we used to see, I mean, we used to see that, like, how different people approaches the questions and all, so that we can cover that in the collab. I mean, uh, we get the new ideas, no, just let's say, I mean, just in the last time only, during the session only, I mean, when I was streaming the session, at that time only, I just got to know about this one. What do you say, that pipe forest? So, do you know about the pipe forest?
No, no, I
So
haven't
yeah,
heard. Sir.
it's just a library. Okay. So what is something? What it does is, so when you will use the pipe forest, no, I mean, just when you import the pipe forest, no, then you don't need to import or write these things like from SQL, this one from SQL, SQL import matrices. And yes, if you import that pipe forest, no, library, no, it automatically, it is a collection of all those libraries. So if you import that, it means that by default you have imported all the libraries. I mean, all the famous libraries. Okay, so from where we know, like, obviously, just by going through some other people's, uh, I would say, other people's, this one, I mean, collab and all, like other people's submission on Kaggle and all. So we see like how other people's approaches. Yeah. Okay.
Right, right.
Yeah.
Okay, other people's cargo.
Yeah.
Okay.
Yeah, so you have to see, I mean, definitely you will see. I mean, just I would tell you an example, like the last op last run, op1 was there. So in op1, I was, so due to some, I mean, that was the first time that we were conducting op, so due to some mistakes and all, I mean, mistakes from the, I would say, portal side, what they did, like, by mistaken, they just, for the few minutes, starting few minutes, they shared the answer. So there were 2 3 people who got the answers at the start only. So due to that, we had to manually evaluate the collab. So that, I mean, there were people like, whoever's got the high marks, whether they have, in the real time they have written the code or not, or just their answers are correct. So in that, during going to, when I went through few collabs, then I saw few things. I mean, I was not doing that much in collab only. We can search about the different libraries and all. So we also searched that, but one people had one method, I mean, that I haven't ever done. Okay, so like that only, I mean, when you'll see the other peers collab and all peers method, you will get to know, I mean, some other logics to write the same code. So these things happens, I mean, different people have different approaches, different thinking. I mean, you can think, no, I mean, for the same, let's say, you have to do that, this one, I mean, you have to just get the data of all the categorical variables, and let's say, numerical variables. So how can you approach that? Okay.
Right, right.
Yeah, so
Okay.
let's say, just I'm saying that,
there can be two. Just whatever currently whatever the method I coming in my mind, I'm saying that yeah. Let's say just we can see that when we search for the description, no. Okay, so in the description by default it is the, like something like when it's numerical, then only it gives a description. I mean mean, mode, median, all those values. Because for
Right.
statistical data it doesn't give any meaning. No? So but by default it is there. But when we have the parameter include. So if we put that include, by default it is include equals numeric. And if we put that we said that include equals all, then we get all the parameters including numerical and categorical. So obviously numerical plus categorical, and somehow we are able to subtract that numerical from there. No, then we are able to get the categorical all the categorical values. So whatever
Right. Right.
yeah. So yeah, you can write this in any format. I mean you can use that description also to get that I would say that numerical features or categorical features, or otherwise you can directly from the codes also, from other methods also you can get that. So it is like that. The different people may have different approaches, and there would be some approach which is better. Okay, so that is what I.
Right.
Otherwise, you can just run a loop. That is what I. Second method can be there. I mean, using that description also, you can get that categorical features list, or second method can be a loop. Just first you collect that all the numerical features, then just go through the list of all the all the feature names, and just remove all the numerical features. So yeah.
So in Kaggle competitions also, people are not using these simple machine learning models, or are they?
So see, in Kaggle competition, I'm telling you, see, people are using the Kaggle competition is all about that feature construct, yeah, feature engineering. Okay, so most
Okay.
of the scores, I mean, yeah, these simple models are, yeah, in the Kaggle competition, you will see that. See, I'll tell you the basic idea of Kaggle competition. Just you just what you do, like you just keep your data set, just clean a little bit, at least little bit, like basic cleaning. Just do the basic cleaning. I mean, just remove the null values, just put that. Remove the null values, remove the outliers or something like that. Yeah, just do, or maybe just keep the outliers and yeah, just try. Just to put the extreme, yeah, XZ boost or random boost, yeah, or yeah, gradient boost model. You will be directly in top 50%. Okay, from there you have to, if you want to improve your score, then you have to do something like feature engineering. I mean, you have to clean your data, or just try different thing. I mean, just remove some outliers and see what results happen. I mean, or just to try to converge. There would be some features which is, I mean, let's say I'm giving you the length and breadth. So why to keep both? Just keep that area. I mean, obviously these things will work. So yeah, you have to do these things. Just create some new features, or just try to remove some features, or just remove the outliers and see the what is the like a particular outliers of particular column, and then check whether your results are improving or not. These things will improve your score. Okay, so yeah, in the Kaggle, obviously, if you want to you get the good score using linear regression, logistic regression, yeah, it won't happen. That is what I'm saying, that mostly the tree based models are famous. I mean, yeah, XGBoost and gradient boost, these things are famous over there. And yeah, deep learning, if you have large amount of data, these things are there. And as you said, as you said, yeah, these models people don't use. I mean, obviously, you those models will give you the better accuracy. I mean, when you will go through, when we will go in week 8, week 9, 10, no, after that, just run the code. I mean, just try to check like which model is giving you the better accuracy. Always, I mean, in the most of the cases, uh, random forest and exhibit, these models will give you the better accuracy, much better accuracy than these things. I mean, normal linear regression, logistic regression models.
So
But
people even combine models, and I don't know. To me, that doesn't make much sense. But why would you decide to do that? I've seen people combine even tree models.
uh, something like just to give some example. I mean, what you okay, tree based model, they are combined. Yeah, see, you do anything, so what is happening there, no? I mean, let's see, people are doing different things. I mean, just see, just you can do one thing, no? I mean, let's see, you have null values. Okay, in particular
Okay.
column you have null values. So what you will do, I mean, just you can remove that. There can be many options. I mean, you can remove that first. If you have large amount of data, you can fill with mean value, fill with median value, or one thing also, okay, you can do, no, just make it as a target variable and try to just run the random forest model, and then just whatever the value, just take these things are test set. I mean, where you don't have any values, null
Right.
values is there. So this thing can be done. I mean, people do that. I mean, it is not something new,
I
I'm saying.
think imputation also you can use something like KNN clustering or something and impute values now. So
Yeah, that's true. So yeah, that is what I'm saying. I mean, it depends. I mean, obviously, as long as you are getting better accuracy, just do that. Okay.
but sir, better accuracy, but even
I mean,
then you'll be tested on a fresh test set, no? So I don't know. To me, it seems like you're just trying to overfit.
uh, yeah, you can say that also, but in most of the cases, what we see, let's just see here also. Yeah, you can. Yeah, it completely depends on the test set. But usually, what it's a basic assumption is no, okay, sample is just a it's a sample follows the same rules or same distribution as the population is the same distribution which
Right.
population is facing. So you have to
Yes.
assume these are the basic assumptions. You have to assume that based on that you have to work. I mean, see, you have to what is happening here. Let's say you had 100 points and there were 16 points which has null value. So basically you had 84 data point, 84 samples only. So once you got the value for some values for these 16 samples, then your sample size increased to 100. So obviously your model will be you will be able to get the better model. And see, in this 16 in this 16 point in these 16 samples, let's say there were 20 features, so only one feature was missing. It was something like that, no? I mean, only one
Yes.
column was
Yes.
missing. So
Yes.
obviously still let's say yeah, you fill some garbage value here, but still 19 you got 19 features, still you got 90 features, no? Obviously, which will help you to increase your model accuracy. It may there can be also cases like it didn't improve your accuracy. It may happen, but yeah, but high chances are there. I mean, the higher probability is that yeah, it will improve your accuracy of your model. In this case
Sir,
also,
if you were faced with something real, like you had
yeah.
a continuous stream of data and you had way too much data, so would you decide to, work with only some of it? Like, suppose you were getting 3 billion rows of data every minute, would you
Yeah.
decide to work with just 3,000 because model accuracy would be enough?
See, again, this depends on the completely the it depends completely on the data type of data set. Okay, so let's see here. If we have 3 billion data, 3 billion points. Okay, and
Mhm.
continuously we are getting the data as you said. So what I will do here, no, obviously I will take some samples. I mean, let's say 1 lakh. I mean, it depends on my system capacity also. Like let's say we are using collab, then obviously we can't train this much data. No, so what
Right.
we'll do is that yeah, we will keep some an amount of data. Okay, I mean, let's say like we will take 50,000 samples. Okay, then we'll try to run our model using this basic ML. I mean, basic algorithm. These algorithms, whatever is covered here. Okay, so then we'll try to after running those things, we'll do that proper ADA. We'll try to understand the pattern and all. Then again, yeah, we will train our model and let's see like which features are important, which features are not, which feature is affecting to a larger extent or something like that. And then after that, yeah, we will create some deep learning model to yeah to work on this data. Okay, so usually
Right.
people do like that only. I mean, yeah, these basic models are for their basic understanding and yeah, and
So,
yeah,
are people still actively working on new ML models?
yeah. Every I mean yeah, every 10 to 20 days you will see some new paper on some new models. I mean, and number of models, and that's why see your you people I mean our syllabus was there, MLF and MLT was there, so that you understand what is happening what is the base of these models. I mean, how this mathematics is working, then only you will be able to develop some new algorithm and all. Okay, so
Right, right,
yeah,
yes.
yeah, otherwise I will tell you, just see the like nowadays you are seeing that, so like almost what I see, the like, every second or third people is talking about data science. Okay, so what I mean in here, apart from these courses, I since when I was in college, I was just trying to look at some other courses, what is happening in these courses and that course, apart from the college courses, obviously. But so what I saw, no, I mean most of the people, or during our placement also, like there were many some courses, like yeah, 2 to 3 month data science courses were coming on our. I mean, yeah, we used to get the mail and all in our college mail also. But so yeah, I used to saw that, as you used to see that, and there were our few of our seniors. So people they used to say that, yeah, see, you know, the data science, that is different thing. I mean, basic, yeah, the ML algorithm, like how it is working as mathematics. In industry, they won't ask you. Okay, so you should have knowledge of what type of question is getting. They will ask and all. So these things you will learn when you will talk, when you will see these courses. Okay, so I have seen many courses. That's why based on that experience, I'm saying that, yeah, they just teach these things only. I mean, just this model dot fit, model dot predict, nothing else. Okay, so you just understand, like who just the people who just know that what is this, I mean, what is that dot fit dot is predict, nothing else. So how much they don't know. I mean, just try to explain them that loss function, they won't be able to explain. I mean, like just ask them to explain the PCA, what is PCA, I mean, how the different steps are going on. So don't know. That is also not a good thing. And yeah, based on that, I just remember one, I'm able to recollect one point, that that guy about whom I am talking, so he has written one more point also, like there are people who knows nothing. I mean, who doesn't know anything, any mathematical behind this algorithm. Okay, they know just the, yeah, dot fit dot predict. And there are people who knows the complete, I mean, very good mathematics. I mean, they are very good in maths, and yeah, they know all the mathematics behind this. That is also not good thing. I mean, the balanced approach is the best way. Balanced approach. I mean, balanced approach is a good way to start. And yeah, once you learned, once you have started, then yeah, just go through that these things. I mean, go through the basic mathematics behind these things in more detailed manner.
But sir, all these methods that we spoke about, these are all linear algebra based now. There are also non-linear models. Are they also in use?
Yeah, you have to learn. I mean, see, practically, do you think that your data set will follow linear model? I mean, these the ideal data set usually follows that your linear models and but in real life, do you think so? Yeah, it is not like that. I mean, you have to know all these things. And yeah, mathematics, I would say, yeah, see, for the starting, if you are starting the courses and all, then it's good. I mean, whatever you are saying, that is good enough to start. And yeah, more things which will come in your line, you have to learn that.
Right, right. Got it,
Yeah.
got it.
Yeah, so anything else anyone want to?
Sir, decision functions shape OVR. What is it trying to do?
Just see this one versus decision function OVR. Is it? I mean, see, OVR was not a decision function, no? See, OVR is something like, oh, decision function shape, you said, no? Let's see. Just I also will also see that right now. See, one versus one and one versus rest approach, no? Okay, whether to return one versus rest. Yeah. I mean, it depends when you have multi-class classification model, no? Like then you have to use that whether to return a one versus rest decision function of a shape as all other classifiers, or the original one versus one decision function of Libre's web, which has I also need to read that. I mean, currently I haven't read this one.
Right. I think yes, this was discussed in MLT. So if there are many classes, then
Yeah. Yeah, then you have to go through that one versus one approach and one versus rest approach. So you would have read about this, no? One versus one and one versus
yes,
rest approach. Yeah.
yes, sir.
So,
Because the decision boundaries will look different in both those
yeah.
cases.
So yeah, that is what it is. Yeah. So anything else? I would say, see, just practice. I mean, just what approach, ideally I would say suggest, no, just in
Mhm.
every week just try to just try just go through some data set and just try to run the models, I mean different models, just try and just do the cleaning part, I mean just yeah, in the cleaning part only most of the time goes. So here you are whatever the data is being used, no, those are very clean, I mean you don't have to do anything, any kind of
Yes,
clean.
that's the problem. No, that's
Yeah,
what I was thinking, that there was nothing that we had to do, not even
yeah,
normal, stuff like regular expression and all, even we didn't have to do.
yeah. So let's say I mean what I am assuming, no, there would be few people who would be able to just, let's say, like recently I was going through one question, so where we have to just something like mm, so let's say we have some columns, okay, this one column, this two column. So what I had to do is, uh, okay, so it's okay. So what I had to do here is I had to uh, combine the value of this one based on this one. I mean, let's say these are the, we have to put the main value of this one. Okay, let's say we have y1, y2, y3, x1, x2, x3. So we have to group these values. I mean, just let's say like we have to give the average value. We have to keep the average value. Okay, so but we have to group this one, and yeah, based on this grouping, we have to combine these values. So something like that, just based on all the values which is related to x, and yeah, we have to group this value, and yeah, we have to just take the mean or something, just we have to sum this value. We have to create our model, something like that. I mean, we have to just do this feature construction part. Okay, so if I'll what I'm assuming, like if you'll ask here, and means who is what is new to this field, I mean ML field, they won't be able to do. So why it is, I mean, none of the course we are encouraging student, in none of the chapter we are encouraging to do the data cleaning. I mean, every time we are understanding, we are in the course we are covering some new models. Okay, because obviously you have just 12 weeks, so yeah, everything can't get covered in the course. Okay, so that is what I'm saying. I mean, you have to, you will get this kind of need when you will just go through when you will go through the different data set, just as you talked about the data, I mean that, no, time part, I mean date part, we convert it in the
Yes, sir.
cyclic format. Actually I have done that in some of the collab. I would have some collabs where I have done that. Okay, so yeah.
So not just that, sir. One more big problem that I have seen very often is that one class will be significantly overrepresented. So I was working with a data set where, you know, uh, I think it was men, women, and other genders. So men was about 90%, women were 7%, and the other gender was 3%. So all conclusions did not make sense. And even if you did oversample, I don't think I don't think you should oversample in that case, because naturally the population has only that much. So I didn't know what to do because the classes were so imbalanced.
Yeah, yeah. So see, as you said that, yeah, in the imbalanced data set, you can go through that. Yeah, you can use this more technique. But apart from this, also, I would say that there are. I mean, in that case, also, like you have to go see like which evaluation metrics will work better. You can't you go through in that in that case, you can't go through that accuracy. I mean, yeah, you have to see that precision and recall. So these things you have to decide. That is what I'm saying. That yeah, these things
Also,
don't get
but
decided.
SMOT is also synthetic data, no,
Yeah, yeah,
sir?
yeah, yeah. So, but what it does, no, I mean, it helps you to get the best model. I mean, let's say we had 100 points. Okay, I mean, let's say we had 100 in 100, as you said, like let's say 80 is the male. Uh, okay, 12 is female. Okay, so three is yeah. I mean, yeah, eight is it will be. Okay, let's just convert it. It's okay. Just convert it to eight in other. Okay. So what will happen here is you created some model. If I'm using adding some synthetic data, then it is giving some good weightage to this one. I mean, let's say 20, it is giving the good weightage to this one. let's say just we added 20 points in this one. Okay, so now what you are saying that it is just synthetic data, that's true, but still if we have just increased the female value, then there are high chances. No, I mean earlier the chances were that like 90 times it will 90% of the time it will predict as a male. Okay, but now that percentage decreased. No.
Yes, sir. Yes. Is there not a way to do it using some weights or something? Because I had seen that in sampling, I think sir was discussing. I think sir did discuss imbalanced data classes somewhere. So stratified sampling or something. I forgot.
Yeah. So what do you want to say? I mean, just say that.
No.
What?
So yeah. So I'm asking you that. So even dealing with imbalanced data set has a lot of ways. Which one would you
That is true.
choose?
So again, it is again here also I will say that yeah, just try out a different method and see which one is working for your data set. That is the, I mean, for the most of the question, this would be the answer. I mean, there are very few things. I mean, for that you can say directly, yeah, this one will be better, that one will be better, or yeah. Otherwise,
Right.
yeah, it is like that only. I mean, just try and see. Otherwise, or yeah, if some people has done that, like see for recommendation system, yeah, K-means is working better. So it is like that. It is just like some other people has done that. So that's why you are saying. That's why I am saying, because he has some other person has tried both all the methods, and yeah, that's why they are using that. Or yeah, so which distance matrix is work, or which distance matrix is work, yeah, like cosine distance matrix we use in those cases. All these things depends on that person. I mean, some other person has done cross check. So either you can cross check that, or if some other person has done, then yeah, you can directly use that. It is like that only. So yeah,
Right. Okay. Okay. Right.
yeah, that's all. So at least somehow we covered the 2 hours. But I thought like yeah, 30 to 45 minutes would be enough to cover this session. Yeah. So I hope I was able to convey. Yeah, you would have gained some knowledge from
Yes,
this.
sir. Thank you,
Yeah,
sir.
yeah. Thanks. Thanks, Ruti, and yeah, thanks, Abhi, Sudhankar, Vivek, Paul. I mean, yeah, earlier two people were there. Those they are not here. I mean, they left. Yeah. Okay. Bye, everyone. Good evening. Yeah. Have a
Bye, sir.
good day. Yeah. Bye.